Page 4 of Case Study on Lake Michigan, and we're now asked to chart some data here. So given Flora's findings, fill the missing data on the axes of Figure 4 below to depict the data Matt found for that Secchi disk. So remember, we were dropping that disk down into the water. All right, so this is actually kind of a combined effort thing, so we'll use some images from page 3 and bring them in a moment. Let's talk about the axes though. So we have our x-axis, as usual, down here. This is our independent variable. Okay, and I don't need to write all that. The y-axis up here is going to be dependent. And for our x, we have years. So again, time, and time is a great one. Whenever you have the choice, usually you're putting that one on the x-axis because it's really tough to change time. Yeah, we'll just leave it at that. The depth we're seeing on the y-axis here is in meters. So again, if you put your arms out to the side, usually you have an arm span that might be a meter or maybe even more than that. So what does this really mean? Well, this means that we're dropping our Secchi disk down a certain depth. So here we're starting in 1989 with a depth of 6 meters. So if you can envision 6 meters here, so a meter is, about 3 feet here. If we have 3 times 6, that's 18 feet. So I'm thinking, maybe a boat, maybe an RV, that sort of length, if it's a very short RV. That's the typical length that we're talking, that we can drop a string with that Secchi disk down into the water and still be able to delineate that white and black area from each other. So that's rather impressive in my book. I think that's a pretty clear area of water. I would consider swimming in that. So let's keep looking at our data points here. It looks like from 89 to 92, we're kind of bumping around 6 to 8 meters. Now, additional data can be found in a sneaky way. So we're going to go back to page 3. Alright, now that I have images from page 3 and page 4 together here, let's utilize the data from page 3 and plot some points on page 4. So, down here in our bar graph of phytoplankton production, we have initially some data from 1983 to 1987. This data does not fit on the scale for the page 4 image there. So our figure 4 is what they label that. Instead, we start in 95 to 98. Okay? So 95 to 98, I would find that here on my y-axis. So 95 to 98 are what we're looking for. And they give us somewhere around, 800 milligrams carbon per meter squared per day. And we know that that's a little bit less than what we saw in 83 to 87. So remember that the more organisms you have, the more cloudy it's going to be. Okay? And the less organisms we have, the more clear it's going to be. So I would imagine, since 95 to 98 is in between the data points here, so we've gone from cloudy to clear, we're probably going to lower our Secchi disk down a little bit deeper in the years 95 to 98 compared to what we saw in, the early 80s, early to mid 80s. So I'm going to put depth in meters, maybe, maybe 12 meters, or maybe even 10. But it's definitely an increase. We're sitting in our boat, and our Secchi disk is dropping down, and we can still see it. And it's a very clear lake compared to what we saw in the 80s. And so we could go a little bit further, a couple more meters of string play out. All right, let's move on to our next set of data points. So 2007, 2008 were even more clear. So phytoplankton has decreased, so we're not making a cloudy particulate matter in our water. So in 2007, 2008, let's go right up here. So we are missing chunks of time. And, for our purposes today, I think this will work just fine. Water clarity increased, so maybe our Secchi disk drops real low, maybe down to 18 meters. I don't know. So if I had to connect all these dots, I would probably have an upward trend. And that would complete figure 4. Bottom of page 4 is question number 6. What factors in the environment would make one kind of alga increase while another decreases? So there's many different answers because there are many different factors. This is a multifactorial system again. A lot of people talk about, whether or not there's sunlight involved here. So sunlight. And this could either be more sunny days, which usually people assume because plants like sun for the most part, and they don't really think about maybe cloudy days, but that could be something that we'd need to talk about too, either. All right, CO2. Okay. So we have a lot of CO2 issues right now that we're talking about in politics, and we think that our CO2 is increasing. But it could be decreasing in other ways too. If we're talking about a water system, there's CO2 that has to perfuse through the lake, and it can either be produced or consumed in the lake too. So, we don't know what's going on, but we have to talk about CO2 and make sure that we took it both up and down, so increase or decrease. Now, plants reproduce at a certain rate. So, rate of reproduction. And what I mean by this is that, some things double or increase or reproduce more quickly than others. So if you look at a human, in order to be of reproductive age, you're probably teenager, okay? We know that it takes a couple years here, a decade or so, to get even close to the reproductive age that you could have young. If you look at rats and mice, though, that is an entirely different system. A lot of your rodent population, they are only pregnant for about 21 to 23 days. So imagine a human pregnancy, 21 to 23 days. That would be amazingly fast. And so, this is why your rodent population can have multiple litters in 1 year. So many, many babies. And that rate of reproduction is much higher than the human rate of reproduction. We also need to talk a little bit about other organisms that might prey on algae or something else that kind of tips the system one way or another. So we'll talk a little bit about some invasive species next. And predator-prey. Finally, we started this conversation talking a lot about phosphate. So we're going to probably come back to this too, because as organisms consume other organisms, so they eat them, they're going to produce waste. And some of the waste drifts down to the bottom of the lake and will sediment and slowly release different moieties. So, phosphate could be increased just because things are eating and things are pooping at a higher rate.